Hello and welcome dear viewers to the another interesting topic on dissolution testing, and the topic is non-sync condition in dissolution testing. So you might have heard regarding the sync condition and non-sync condition. So always the sync condition is used for dissolution testing, and there are advantages of sync conditions. Also, the sync condition is required to be proved for dissolution testing and to perform the dissolution testing, and always the sync condition is a part of the dissolution development report, but non-sync condition can also be used for dissolution testing, and it has some its requirements and uses. So first we will see the basics of sync condition. Sync condition is the main requirement for any dissolution testing. It is the volume of dissolution medium that is at least 3 to 10 times the saturation volume. In simple words, the volume of media being at least 3 times of that required to form a saturated solution of the drug substance. See, sync condition is generally met with the formulations and with the APIs which are having high solubility, and sync condition is somewhat difficult to meet with the poorly soluble molecules. And for poorly soluble molecules, generally the salts are used in the dissolution medium, like sodium lauryl sulfate is there, twins are there like polysorbate 20, polysorbate 80, and these surfactants and salts, these are used. Mainly these are known as surfactants. Then many of the times, if solubility is not obtained, that time the apparatus like USP3 are used, USP type 4 is used. So sync condition is most important thing. If sync condition is maintained, that time the amount of the drug already dissolved in the media does not affect the dissolution rate as the dissolution run progresses. So this is the information regarding sync condition. Now what is non-sync condition? If the volume of the dissolution medium does not dissolve the 3 times of the drug or the dose or amount of the drug, then that condition is called as non-sync, and you can say that the sync is not achieved. If you have a tablet of 1 gram of API, and if the dissolution medium volume cannot dissolve 3 gram of the API, that time you can say that sync condition is not met. And if the dissolution media is able to dissolve 3 gram or more of the API, that time you can say that the sync condition is meeting. So how sync condition and non-sync conditions are determined? So these are determined based on the solubility of the drug in the dissolution medium. Saturation solubility or equilibrium solubility studies are required to be performed. See, once you perform the solubility studies in different pH medias or in different medias with surfactants or solubilizers, then you can have important information about the solubility behavior of the molecule, and based on that you can determine the media volume to dissolve the 3 times of the dose, and that means you can be able to have the sync conditions. Sync conditions are required or these are desired, but these are not mandatory. You can find this information from FDA guideline. In 1997, FDA has published the dissolution guideline, and in that it is stated that sync conditions are desirable but not mandatory. Now what is sink index? So sink index is a very important type of factor which is required when you are studying different strengths. So sink index includes the solubility of drug, that is CS, volume of the dissolution medium, and the dose, that is the total amount of the drug in the test sample. In test sample means in the formulation. So SI is equal to CS divided by dose divided by the volume. So if you have the solubility information, if you have the volume of dissolution medium, and if you have the dose, then you can determine the sink index. And sink index is governed by the dose and the solubility of the API. So if you increase the dose, then you will get the lower sink index. That means if the strength is lower, you will get the faster dissolution, because with lower dose sink condition will be maintained, but sink will go on decreasing with the increase in dose. That's why whenever you are working on the number of strength of the same formulation, that time you will observe that the lower strength show faster dissolution compared to the higher strengths. Then can we perform the dissolution testing if sink condition is not achieved? So definitely yes, we can perform the dissolution testing in non-sink conditions. See, some drugs are very low soluble, or these are very poorly soluble, and these have high dose. So it is very difficult to maintain and to achieve the sink conditions. And generally mild dissolution conditions are required, like 900 ml or 1000 ml of the media, and with the minimal use of surfactants. So with these conditions the sink is not achieved. So instead of getting solubility of 3 times of the dose, only 1 time or 1 to 5 times can be achieved, and thus dissolution is to be performed. Then some formulations are designed on the basis of the solubility enhancement technologies. The examples are amorphous solid dispersions, and solid dispersions are made by the hot melt extrusion, spray drying technology, and other technologies like precipitation technology with using the different solvents. So we are not going in that detail, but always remember that sometimes the solubility enhancement technologies are used for the poorly soluble APIs like BCS class 2 and BCS class 4 molecules. And if the molecule is showing very low solubility or very poor solubility in the medias across the pH range, that time it becomes very difficult to achieve the sink conditions. So non-sink conditions can be used that time for dissolution testing. Now what leads to non-sink conditions? As we have mentioned that high dose, then low solubility or poor solubility of the molecule can lead to non-sink conditions. High dose is generally utilized in modified release formulations, as the formulations are once daily, so dose is higher, and if these formulations contain the low soluble drug, then it becomes very difficult to achieve the sink condition with this type of formulation design. Then solubility enhanced formulations like solid dispersions. Then drugs with very low solubility. Some of the molecules show zero solubility in all the pH medias. Also, if you use the surfactants, that time also it is difficult to achieve the sink condition. So that time dissolution is tested, or dissolution test is done in non-sink conditions. If dissolution is to be performed in non-sync conditions, then it is required to be proved that though there is a non-sync condition, still the dissolution conditions and specifications are having discriminatory power. This is very important statement, and always remember that though you are using the non-sync conditions, you cannot say that, or you cannot mention in the dissolution development report that because of non-sync conditions the dissolution test is not discriminatory. It should be discriminatory, and it is required to be proved that the dissolution test has the discriminatory power though there is non-sync condition, and based on that you can get regulatory approval for the non-sync condition dissolution testing, and it can be proved based on the different formulation designs and with different technologies. So use different formulations, use different technology for making the formulation, and prove that the dissolution conditions are discriminatory though there is a non-sync condition. Now non-sync conditions are used in research and development and also in many of the QC dissolution testing. So what are the uses? So the non-sync conditions for dissolution testing are used to study dissolution and correlation with the in vivo absorption. Suppose you are having the reference and test formulation in your hand and you want to study the exact behavior of the reference and test, then non-sync condition can be very useful. This condition can give the clear indication whether the reference product is showing higher solubility and higher dissolution rate than the test formulation, and based on that you can understand the true solubility and dissolution reflection between the formulations, between the test and reference formulation, and between the formulations with poorly soluble drugs. If you are working on a molecule which is having low solubility and you are working on the polymorphs, you are developing a different polymorphs of that molecule, then non-sync conditions can be used to discriminate between the true dissolution behavior and true solubility of the different polymorphs. Then non-sync condition is also used to study the solubilizing effect of different solubilizers and polymers on solid dispersions. So solubilizers can be studied. Also precipitation inhibitors can be studied by using the non-sync conditions. If you use the sync conditions, then it will be difficult to understand the effect of different excipients or different functional excipients, and if you use the non-sync conditions, then you can understand the true behavior of these functional excipients. Also, by the use of non-sync conditions, we can simulate the in vivo condition for high dose formulations and for the formulation containing poorly soluble APIs, and also for the slowly soluble formulations or slowly eroding formulations or slowly dissolving type of formulations and the modified release formulations. So sync condition is very important. On the same front, non-sync conditions also have their own uses. These are the conditions for discriminating the formulations based on the excipients, manufacturing process and polymorphs of the API. So you can discriminate between the use of excipients, functional excipients, manufacturing technologies and the polymorphs of the APIs. Also different salt forms, or you can study the difference between the base form of the API and the salt form of the API. So this is regarding the non-sync condition uses. Dissolution is a very vast topic, and if you learn, you will enjoy this topic, and that's why I make videos mainly on the dissolution testing. It is a heart of the formulation design, and also it is a link between the in vivo prediction, in vivo formulation behavior prediction. So keep watching the Pharma Learning in Depth channel to have understanding of these different topics. Thanks for watching the video. Kindly do like, share and subscribe to the Pharma Learning in Depth channel. Thank you.